All right, folks, here's a video on 13, 14, 16, 17, and 21 from part 4 of U substitution. Okay. Here we go. Okay, so if you have questions on 18, 19, 20, the answer key is updated. Okay, so number 13, we're going to do a U substitution with this based off U substitution methods. And we're using the first one, okay, which is when the exponents differ by 1, U sub the top one, okay, or the higher one. So here's a higher one, U sub that, go through the motions, and you have this right here. They wrote this, but then I just divided both sides by, or divide both sides by x squared plus 1, and I get this when you isolate dx. Okay, so this right here becomes a big U. Dx becomes that. Okay, and we get some canceling going on. This cancels with that, and you get 1/3 u to the power 4, 1/3 u to the power 4. Use the antiderivative, plug back in u for x cubed plus 3x, and you are done. Okay? Number 14. Okay? Number 14, here we go. Okay? We're going to set u equal to what's inside the tangent. Okay? I'm going to set u to what's inside the tangent. So, and that's based off of this trig function right here, or this u sub right here. U sub inside the trig. Okay? So u equals to this derivative of both sides, okay, or derivative of each side. They made a mistake on this derivative over here. Oh no, sorry, it's a constant. I'm tripping up. So this is good, and then you multiply both sides by √3, and dx equals to this right here. Okay, so we're going to do a basic U substitution over here. So this original problem, this becomes a U, or first of all, they separated this out using the addition subtraction principle of derivatives, of integrals. And anywhere you see this, we put a U. So this becomes U, that becomes U, okay? Anywhere we see a dx, we're going to put a √3 du, okay, right there. And the √3, what they forgot to do was extract this, okay? Extract the √3 out of the integral. So there should be a √3 here, okay? And this becomes tangent squared u. And using the formula here from your list of antiderivatives, okay, I'll put that in blue. That's not the best color. Gray. Still not good. Whatever, you know what I mean. So this, okay, becomes that. That through this right here. Okay? And there should be a √3 right here and a √3 right there. So boom, boom, and then boom, and then boom. Okay? And they resub the x over √3 here and here, right here and here. And just, if you want, you can distribute this over here. √3's will cancel in this term, and you'll be left with an x, and you'll have a √3 in front of this tangent. Okay, and here, for this one, they just use power rule. Okay? They basically just use power rule. Here, 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 all the way down. Okay? Let's see. Got you. Now, number 16. Okay. 16 is just a U-sub problem with antiderivatives. So we want this, which is right here. These are in terms of, the upper lower bounds are in terms of x, so we write it in terms of u. So we let u equal to the 2x, okay, go through the same motions, and then we convert the upper lower bound, okay, from u's to x's and become 4, 0, okay, and this 1/2 gets put right here, all right, and this is given to us. It ends up being 10. 1/2 times 10 is 5, okay. Now 17, same idea, okay. Using the addition subtraction property of integrals, this becomes this, okay. So the integral of that's easy, antiderivative of 2 is 2x, and because this is not a clean x, we're going to use u substitution, all right, go through the motions, all right, and then sub back in the 3 du for dx, all right, right there, and this becomes u, all right, and the 3 gets extracted here, which is what we got here, f of u right there. 6 and 0 get converted to 2 and 0 based off of this, and this ends up being given to us right here. It's 5, and you just evaluate the easy expression here, okay. All right, so that's 17. Last one. So 16 and 17, you basically just do a u substitution, and you end up, it's not a coincidence because, well, you end up coincidentally getting this right here, what's given. That's just, it's not a coincidence because they set it up so that that coincidence, quote unquote, will happen. Number 21, okay, it's actually a simple problem. We connect the dots starting here at 1, 0. And it looks something like this when we follow the trend lines, okay? And then it flattens out. It looks like there's an asymptote, okay? It looks like there's an asymptote right here, all right? And when you graph these all on Desmos, you should know these graphs roughly, okay? By heart, in your head, memorize. The one it closely matches, okay, is, so it looks like it might be cosine, but then cosine, if you see it bounces back up, okay, because it's a wave, and this looks like an asymptote, all right. So and it bounces and crosses the x-axis. This looks like there's asymptote above the x-axis, and the most common one, or the one that most closely matches, is E, which is that graph. Now, if you all else fails in the AP exam, if you don't know the graph, okay, just start plugging in numbers and just seeing and just graph the rough trend. These you should know by heart right here. This is a sad face parabola that cuts all the way through, whereas there's an asymptote, so it can't be B. This semicircle, okay, you should know that. This you definitely should know. Okay, the only one that might be troubled is that one, and you just plug in. Okay, and you know it's going to be a mirror image because of this x squared. All right, whether it's -1 or +1, you're going to get the same y value. Whether it's -3 or +3, you get the same y value. Okay, it's a huge hint right there for E. Thanks for tuning in, folks.